This is a presentation of Chapter 12, Section 4 in the 7th grade textbook, Inequalities. So what we're going to do now is we're going to take all those concepts that we learned from solving equations, mostly one-step equations, and we're going to apply all those same rules to now working with inequalities. And that's what we'll be doing over the course of the next few sections here, because as you can see, 12.4 and 12.5 and 12.6 are all dedicated to that topic of inequalities. So what is an inequality? That's a mathematical sentence that shows the relationship between quantities that are not equal or may not be equal. So it's going to look like an equation, but it's now going to contain one of four signs. Instead of equal to, it's going to have greater than, less than, greater than or equal to, or the less than or equal to sign. An algebraic inequality is an inequality that contains one variable or a variable. The solution set is the set of values that make a statement true. When we have an inequality, there's not just one solution like there is in an equation. There's many solutions. So all those numbers together are going to comprise the solution set. And then a compound inequality is a combination of more than one inequality. So we're going to put a couple different inequalities together in one statement to come up with a compound inequality. So, in the beginning here, they're asking us to write an inequality for this situation. There are at least 15 people in the waiting room. So if there's at least 15 people in the waiting room, that means there could be 15 people, or 16 people, or 17 people, or 18 people, and on up the number line we would go. So we want to somehow say that that number is the same as 15, or something that's bigger than 15. Well, that's of course greater than or equal to, which is the symbol you see in the solution here. Now you're kind of writing this in a word scenario, so we're going to say that the number of people, or if you want to be a little more specific, the number of people in the waiting room is going to be greater than or equal to 15. B, the tram attendant will allow no more than 60 people on the tram. So that means there could be exactly 60 people on the tram, or some smaller figure, 59, 58, 57, 56 people on the tram, something in that area. So here we're going to say that the number of people is less than or equal to 60. Because again, it could be exactly 60, which is what the line underneath means, equal to exactly, or it's some smaller amount when we put less than in. So 59, 58, 57. So the number of people is less than or equal to 60, or the number of people on the tram is going to have to be less than or equal to 60. All right, so now we're talking about graphing inequalities here. Graphing inequalities takes a little bit more knowledge here. You have a knowledge of your symbols because we've just reviewed those in the last question. Now it's a matter of how do we graph them. The graphing is how we actually show that there's all these different answers and not just one. If we were graphing an equation, like we had just been spending a bunch of time on in the last chapter or unit of study there, we would just go to our number line and put a dot and it'd be over. But these are not equations. There is more than one solution here. So the graphing here actually is how we show that there's many solutions. So what you're going to do is you're going to have a number line that represents your inequality. And on that number line, you always want to make sure you have 0 and whatever the number is in your question. Now, since in this one it says n is less than 3, the number in my question happens to be 3. Eventually, we'll get to the point where we have to solve these for whatever the number is, which is no big deal. And then after we solve them, we'll figure out the number we need to plot. When we plot these, we want to make sure we plot these somewhat sensibly, meaning, for instance, with positive 3, I wouldn't put 3 to the left of 0 on the number line because we know that the numbers that are left of 0 on the number line would be negative numbers. All right, so when they are the greater than or less than symbol, they're going to get graphed on the number line with an open dot. When they are the ones with the line underneath, greater than or equal to, less than or equal to, they're going to get to use the closed in dot. And then what we'll do is we'll shade the number line to represent all the other solutions other than the numeric value we've computed in the inequality. The reason we have the two different dots is because, for instance, if we were graphing greater than and greater than or equal to, we would never be able to tell from the shading piece alone which it is, because if I've said to you the numbers that are greater than 3 or the numbers that are greater than or equal to 3, the numbers that most of us are going to rattle off are going to be 4 and 5 and 6 and 7 and 8 and 9 and 10. Well, those are all going to be represented the same way. So the only way we have to know the difference here is what type of marker we put down on the 3. So looking at 2a here, it says n is less than 3. So 3 is not a solution here. All right, if it had the line underneath where we said n is less than or equal to 3, then 3 would be one of the possible solutions. But here it just says n is less than 3. So what I'm going to do is I'm going to go to 3 and I'm going to draw an open circle at 3. And again, that's going to be how I know that it's one of the symbols that does not have the line underneath it right here. Now that's not it. Now I've got to show you where all the numbers that are less than 3 are. So that's our 2 and our 1 and our 0 and all our negatives. So now what you're going to do is you're going to shade from that circle all of those numbers that would be matching that situation on the number line. So we're going to shade the line to the left of 3 now. So from 3, I'm going to shade to the left, that as such, and that's going to show me n is less than 3. All the numbers that satisfy the inequality n is less than 3. Now, this is a compound inequality in number 3, but all that really is it's me doing the exact same thing I just did, but putting 2 inequalities on one number line. So don't let it confuse you that there's a couple different pieces here. It doesn't really change anything. I'll write it back up just so you have a note of it here. Again, when you have greater than or less than, that's when you're going to use your open dot. Greater than or equal to, less than or equal to, that's when you're going to use that closed-in dot or the shaded dot. So you've got m is less than or equal to -2, or m is greater than 1. So where we've got m is less than or equal to -2, as you can see, we're going to graph each inequality separately, and that's how they're actually going to start these here before we can combine them. I'm going to find my -2 on the graph, which is right here, and then I'm going to look at this symbol, and I see this is one of the ones that has the line underneath it. And since it has the line underneath it, that's going to require us to use a filled-in dot on the number line. And that will help me indicate that this is one of these symbols. And now I've got to show you where all the numbers that are now less than the -2 are. We've got the equal with the closed-in dot. Well, the numbers that are less than -2, that's your -3 and your -4 and -5 and -6. Those shade off to the left on the number line. And as you can see, when we come down here, we're just going to combine our two graphs. So I'm going to go ahead and just re-sketch this on number line number 2. Then we've got m is greater than 1. So I'm going to go over to my number line and find 1, and I'm going to put an open dot on 1, because this is one of the ones that does not have the line underneath it. And then I've got to show you where all the numbers that are bigger than 1 are. So that's our 2 and our 3 and our 4 and our 5, and on the list we go. Well, those are off to the right on the number line. So I'm going to shade to the right. And that's going to be that graph of m is greater than 1. Again, I'm going to transfer that down here, and this is then the solution of my compound inequality. What they're saying here, with the shading here and the fact that they use the word or, all right, my solution is anywhere I have a mark. So basically, the things that would not be a solution would be anything in this little area here, because everywhere else on my number line, from this dot to the right and this dot to the left, I'm going to have a mark. Those are potential solutions, whereas the area that doesn't have anything would not be. The other type of compound inequality uses the word and. And when we have an and question, we're looking for places where those shadings or markings, depending on what type of situation we have, are actually overlapping each other. And that's going to be the solutions to those compound inequalities. All right, so let's go ahead and take a look at number 1 here. We're writing an inequality for the situation. There are at most 10 gallons of gas in the tank. So that means there could be 10 gallons, or there's a smaller amount, like 9 gallons, or 8 gallons, or 7 gallons, or 6 gallons, and on down the list we go. So we're going to say that the number of gallons here, and that's going to be a comparison to 10. Well, what do we know compared to 10? It could be exactly 10, or it could be any amount less than 10. So the number of gallons of gas in the tank is less than or equal to 10. Graphing the inequality, P is less than or equal to 2. So the number in my question is 2, so that's where the dot's going to go here. So I'm going to go find 2 on my number line and go ahead and put a closed dot on 2. Remember, the ones with the lines underneath always use the closed dot. And then we're going to do some shading here. Well, since the inequality says less than or equal to 2, the numbers that satisfy the less than part are numbers like 1 and 0 and -1 and -2 and -3, and those would be off to the left on the number line. So we're going to go ahead and shade to the left. One thing that I'm hoping you've noticed by now, it's also the reason that we've always solved equations with variables on the left, is that the shading always goes the same way the inequality sign points when the variable is written on the left. When we write this variable on the left, notice that this sign and this shading go the exact same way compared to the dot. This points to the left, this shading compared to the dot also goes to the left. And if you go back and look at the earlier questions we've done, that's a true statement in all of those questions. When the variable is written on the left, and that's the catch, you always have to write the variable on the left, the shading always goes the same way that the dot points, or the inequality symbol points, rather. Now, this is a little bit different